Thanks for tuning in to SpaceX Daily, Episode 17, coming to you from Vancouver. It's June 29th, 2026. From the launch pad to the trading floor, here's everything that moved today. The 15,000-pound SiriusXM satellite launch on Falcon 9 demonstrates the vehicle's sustained heavy payload cadence, while Starship 40's static fire keeps Flight 13 hardware moving forward. SpaceX launched the 7.5-ton SiriusXM satellite from Florida aboard a Falcon 9. The spacecraft forms part of a constellation refresh and represents a single heavy commercial payload. Its mass exceeds a typical Starlink stack by roughly a factor of 6. The flight keeps Falcon 9 active on non-Starlink missions, even as the vehicle maintains its primary Starlink cadence. Reports indicate the same booster family handled the heavy lift without any structural changes from its lighter payload configuration. While that heavy lift flight shows payload flexibility, the same booster family also maintained high-volume Starlink operations on both coasts. A Falcon 9 from California placed 24 Starlink satellites into orbit. The booster returned for a landing and extended its reuse count. One day later, a second Falcon 9 lifted another 24 satellites from Vandenberg into polar orbit. That West Coast launch added coverage density at higher latitudes. Both boosters were recovered as planned, and observers noted the back-to-back tempo across separate coasts. The missions add directly to broadband capacity and support future direct-to-cell services through onboard laser links that will mesh with the existing constellation. Several accounts track the exact timing of the Vandenberg landing relative to the California flight, underscoring how parallel operations sustain overall cadence. Discussion also centered on how the SiriusXM payload mass compares with typical rideshare stacks and what that implies for future non-Starlink manifests. Unverified posts suggested the next Starlink group may test an updated laser terminal variant. The same engineering margins that allow these quick-turn Starlink flights are now being examined in detail. From an engineering standpoint, the 7.5-ton SiriusXM satellite illustrates how Falcon 9's first-stage recovery architecture tolerates large deviations in payload mass without redesign. 9 Merlin engines must throttle and gimbal across a wider center of mass envelope than a 500-kilogram Starlink stack. Yet the same propellant load and structural margins suffice because the vehicle was originally sized for Crew Dragon missions rather than the lightest possible satellite. That original design choice created excess performance margin that now lets a single booster alternate between high-volume constellation replenishment and infrequent heavy commercial flights without tooling changes or new structural elements. Consider the physics. The first stage must still reach the same velocity and altitude targets for recovery, even when the upper stage carries 6 times the usual mass, so the engines operate across a broader throttle band while the interstage and fairing loads remain within the same certified envelope. The result is that turnaround intervals stay consistent because the recovery hardware, grid fins, and landing legs experience comparable stresses regardless of payload weight. Next, engineers will watch whether the same stage can maintain its current reuse cadence after carrying the heavier upper stage load, because any added thermal or structural fatigue would show up first on the post-flight inspections already tracked across the fleet. That hardware flexibility now extends beyond launch vehicles. Elon Musk stated that SpaceX is assigning top Starship and Starlink engineers to Grok development. The move directly links propulsion and satellite hardware teams to the xAI software effort. OpenAI, Anthropic, and xAI together now account for 21% of global AI compute capacity. The figure underscores the concentrated demand these 3 organizations place on both terrestrial and potentially orbital resources. On the AI front, the reassignment shows how orbital hardware expertise is feeding directly into large-scale AI training infrastructure. Worth keeping an eye on, SPCX closed at its lowest level since the June 12 IPO following the Starship 40 static fire report. The decline occurred despite ongoing launch activity and reflects investor focus on capital requirements for the Starship program. Resolution would require either clearer timelines on revenue-generating flights or demonstrated progress on cost reduction milestones already outlined in the prospectus. The engineering cadence continues across multiple programs, even as the market absorbs the latest static fire data. And a quick market note, SPCX is at $153.23, up 0.3% versus the previous close. Before we go, watch for whether the next Starlink group flies with the updated laser terminal variant observers flagged in the last 24 hours. That's your SpaceX news for today. SPCX is trading at $153.23, up 0.3%. If the show saves you time, a rating or review on Apple Podcasts or Spotify genuinely helps new listeners find it. I'm Patrick in Vancouver. Thanks for listening. See you tomorrow. And before you go, this show is part of the NARA Network, a family of daily podcasts on tech, science, and markets, each one a short, sharp briefing you can finish on the commute. If today earned its place in your feed, here's your next listen. Models and Agents, your daily briefing on AI models and agents. Find every show free at naranetwork.com. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.